Okay, for this lesson, we're going to take a look at arithmetic growth and decay. Like it says, many real-life scenarios can be represented by a pattern of numbers which exhibit arithmetic growth. So this is just like doing our applications for our arithmetic sequences. BP Birthplace Forest program in Calgary enables parents to honor their children by planting a tree when their child is born. At the same time, this shows concern for the urban environment by encouraging the growth of city forests. Some of the trees which have been planted are evergreens, which grow an average 12 to 18 inches per year. The program was launched in the year 2000. An evergreen tree, which is 6 inches high, was planted on June of 2000 and has grown at a rate of 15 inches per year. Two students were asked to determine the height of the tree in June 2011. Joel formed an arithmetic sequence going 6 to 21 to 36 and so on and so forth. Jenna formed an arithmetic sequence beginning at 21 and then going to 36 and 51. If we use the formulas in the previous lesson to determine the student's answer to the problem, then based on Joel said that term 1 was 6, the common difference was 15, and in this case, term 1 occurred in the year 2000, which means that to go to the year 2011, if we go up by 1 every single year, then for Joel, the term number in 2011 would be term 12. For Jenna, she said that the first term was going to be 21 because for Jenna, she didn't start calculating until after the first year of growth. So her term numbers are based on the number of years that have passed, not what the starting year was, which means that she's going from 2001 to 2011, or that 11 years have passed, which means that her term number is going to be 11. But she still has the same common difference of 15. The thing is, in both cases, when we use their formulas, for Joel, if T12 is equal to 6 plus 12 minus 1 times 15, then term 12 is going to be 171 inches. For Jenna, if term 11 is equal to 21 plus 11 minus 1 times 15, then it's going to be 171 inches. Now, in both cases, the same problem works where it says, for Joel's, determine the arithmetic sequence. Tn would equal T1 plus n minus 1 times a common difference. In Joel's case, Tn is going to be 6 plus n minus 1 times 15. For Jenna's case, Tn would be still T1 plus n minus 1 times d, but Jenna's T1 is different. It's going to be 21 plus n minus 1 times d. Why are the formulas different, but they both still work? Joel's is based on the starting year, and Jenna's is based on the number of years that have passed. Now, both of these work in the same way, but the catch is that what n represents and what Tn represents is different in both cases. Now, we need to remember that if Tn is always representing the number of changes, then if I went from 2000 to 2011, there was 11 changes, which means that my n value is going to be 11. If I'm doing it year to year, I do need to calculate the first year like Joel had, and I would include that first year as not year 0, it'd be year 1. So it's going to have a difference of 1 in terms of the term numbers. If the tree continues to grow at the same rate, in which year will it reach a height of 28 feet? Well, all of our calculations so far have been in inches, which means that I need to convert 28 feet into inches. Or 336 inches. From there, I could use either of their formulas, stating that for Joel, 336 is equal to 6 plus n minus 1 times 15, which means that 330 is equal to n minus 1 times 15. I divide both sides by 15, and 22 is equal to n minus 1, and 23 is going to equal n. So for Joel, if n1 is 2000, then n22 is going to be in the year, n23 is going to be in the year 2022. If I do the same thing with Jenna's, I'm going to say that 336 is equal to 21 plus n minus 1 times 15, which means that 315 is going to equal n minus 1 times 15. 21 is going to equal n minus 1, and 22 would equal n. And then the only thing I'd need to take into account for Jenna is that for Jenna, n1 is 2001. She started in the second year, which means that N22 would be in 2022. And I get the same answer for both.